Okay, so the last thing I'm going to do is go through the Vasari interface really quickly and show you the flow analysis, the wind tunnel analysis in Vasari, which can be useful. It's not very accurate, so I think in this case you can't really get any data or feedback about it. So right now it's mainly a visualization tool, but I think it could be really helpful with some of your projects. If you're looking at wind or airflow, you can use it to visualize things that are going on in your building. Okay, so the first step of this, since we're working mainly in Rhino and Grasshopper, is exporting geometry from Grasshopper or from Rhino and bringing it into Vasari. The Vasari uses mesh geometry, which is really good because we're already mainly working with meshes for our other types of analysis. So to really bring in your form, all you really have to do is select your mesh, the meshes you want from Grasshopper, and then you bake them into Rhino. So here I'll just hide all the Grasshopper stuff. And here we just have our exterior facade meshes. And then once we have the meshes, we can select all of them, go to File, Export Selected. And we want to export them as a DWG, AutoCAD drawing file. And I'll just call this export. And you can keep all the defaults same. If you're importing other kinds of geometry like curves and surfaces, you can mess around with some of the settings, but if we're just exporting meshes, it's really easy. We just use the defaults. Okay, so now I'm going to load up Vasari, and again, you can download Vasari free online. It's a beta product, so each version lasts for a couple months, and then you have to reinstall it basically for the new version. So we're going to start a new file. So it'll load up this blank document. The first thing we want to do is create a mass object. So all the analysis in Vasari happens on these mass assemblies. When we create a mass, it's really like a shell, or like you can think of it as like a layer maybe of geometry. So we open that up, and then we go to click on the home key here, import CAD, and then we'll go to where our export is. Here's our export DWG. Here there's some settings that could be useful. First of all, units. You should specify what units we're working with. You can do auto detect. It'll default to meters, but it's always good to specify exactly what the units are. And then positioning, we want to switch to origin to origin. In Rhino, we're always working at the origin, so this will bring it into 0, 0. But you always want to specify origin to origin in case you're bringing in different pieces of your geometry onto different mass layers. You want to make sure they all kind of drop into the right place. It's an easy way to keep track of that. Okay, so we'll hit open, and it'll basically just dump our surfaces into this model, and then we can finish the mass. So the mass is basically containing now all the surfaces. It'll give us this warning saying we can only do certain things with meshes, but that's okay. We can do what we want with them. The only thing we're going to do here is to do the wind analysis, because it's really the one thing that isn't contained within Grasshopper and Ecotect. So if you go to Analyze, first you can click on wind rows, and this will allow you to set the location of your project and also give you initial information about how the wind is performing. So this works through the same types of weather data files that we used in Gecko. If we go to open weather files, again, you just navigate to where your Ecotect installation folder is. So AP4, Autodesk, Ecotect, weather data, and we'll select New York. So there's an underlay of the geography. There's actually, it tells you which weather stations are in your area, and then it'll give you the prevailing winds in your area. Okay, so you can take a look at this, and then this is the information that is going to be used actually for the wind tunnel analysis. So you can close that and go to wind tunnel, and this will load into a separate window and give you this interface for looking at your wind analysis. So by default, the wind tunnel does a two-dimensional analysis. So you can see here there is a two-dimensional plane, and it's basically cutting through your model, and it's analyzing the wind behavior at that level. So it's not looking at the whole volume of the space. It's just sending wind vectors through that space and seeing how they deform or how they behave. And the deformation here reflects the data in analysis, which is the wind speed. Okay, so deformation doesn't mean that the wind is moving down or up. It's just a visualization of the wind speed. And here you can see that everything's kind of this yellowy orange, and then as the wind goes around the building, it gets slower, and in some cases, when it gets channeled, it'll actually speed up. Okay, so you can use this to analyze basic patterns of wind around your building and site. You can move this down, and every time you move it, it'll start to recalculate the analysis. You can also turn on and off certain aspects of the visualizations. For instance, you can just turn the displacement feature off, and now it's just a 2D visualization. The wind direction is set by you, so by default it will bring in your local wind analysis into here, but you actually have to move where the wind's coming from. So by default it'll start in the direction which has the most intensity of wind, but you can also move this around to look at other key moments. Okay, the tools above here are navigation tools. You can basically snap to a plan view, and this will give you a kind of a good view of what's happening. You can show and hide different aspects of this interface. You can start to hide the local wind data. This will stay active, so you can change the direction. You can show and hide your geometry itself, so you can get a better look at just the wind. So that is 2D analysis. You can also do the analysis in 3 dimensions. So if I select 3D, it takes a while to basically build the model. It's a lot more computationally expensive to do a 3D analysis, but it'll take some time. While that's loading, to do 3D analysis, we can turn off the 2D visualization, and then in 3D volumetric, we can turn on the 3D volumes. By default, it's going to give you this point cloud where each point is visualized in terms of wind speed. Depending on your resolution, it's really hard to see what's going on. You can see here the resolution is way too high, we can't really see. But you can play around with a lot of these other display options, and these can be useful for different things. By far the coolest one is probably flow lines. So flow lines will actually start to shoot flow vectors into your model, and they're going to deflect and follow your model like the wind would do. And there's a lot of parameters that you can tweak to make this work. So these will still follow your original wind direction. So if you want to change the direction that the wind is flowing in, you can change this angle. You can also click on this flow line settings, and this will give you a lot of settings for the flow lines. You can change the surfaces that the lines are projecting from. So here we'll just switch to the front surface and click apply. So now they're projecting from the front. You can see how they're moving around the building, and they're also being visualized according to speed. So going from red and then blue and yellow. You can also change how these are visualized. You can make them fatter, give it a more kind of volumetric readout. You can also change some parameters for the boundary surfaces where the vectors flow from. And here you can set the min and max height. So basically you constrain your boundary to a thin slice and see, again, get like a more of a 2-dimensional analysis of what's happening just at certain heights of your building. You can change also some other things like the length of the segments, the age, so how long the segments have before they degrade. And all these things will affect your visualization, but they also have an effect on your computation time. There's no like output settings. I think it's like an exclusive data, like it's still experimental. This is like what you see is basically what you get with this thing right now, which I think is like a pretty cool visualization tool. It's super non-specific and won't really like prove anything. It also doesn't support exporting data or image or video, but you can use something like Cam Studio or like this kind of screen recording software to record video, or like screen capture. It's those. All right, so I think that's all I'm gonna do for Vasari. Again, you can figure out how useful it is for your own process. I think it's nice because these kind of tools, like they don't yet really exist on the consumer level. There's a lot of flow software where you can use like SolidWorks, things like that. But Vasari is really trying to make this kind of analysis like really come earlier on in the design process. So really like something that can really quickly inform the way your design is happening. If you design within a Vasari, obviously this is really quick. Like you can mask something up and get the data back right away. But even with using Grasshopper, I mean, it's still pretty quick. For instance, if we just wanted to now visualize how our fenestration is affecting our the wind flow, we can basically bake just the fenestration, select this, export it to DWG, and then create a new mass, import it again, and then rerun the analysis. So it's still pretty quick, you know, a lot more so than some of the industry standard flow software.